Hello guys. Welcome back to Statistical Academy and Research. SAS offers some functions that have specialized purposes. Let's consider a very common issue, dealing with variable type. You know that variables in SAS are either character or numeric, and there are certain actions that depend on data being specifically character or numeric. For example, arithmetic calculations require numeric values, and character functions, such as substring or scan, require character values. What happens when you try to perform an action in the data step on a variable that isn't the proper type? Let us learn. Before we move further, don't forget to hit the subscribe button and leave a comment with your thoughts on the topic. If your code specifies an arithmetic calculation on a character value, SAS automatically attempts to convert the variable values for the purpose of evaluating the expression. Sometimes the automatic conversion is successful, as you saw with the salary variable. Because salary only includes standard numeric values, just digits and decimal points, SAS can interpret the character strings as numbers. But sometimes the automatic conversion doesn't work. The values here in this variable include commas, so they cannot be interpreted as standard numeric values. Instead, they're written as missing values in the automatic conversion process. Similarly, if you use a numeric variable in a character expression, SAS attempts to convert the values from numeric to character. Sometimes it might work, and other times you might get unexpected results. To control data conversion from one type to another, you can use special functions. The input function converts a character value to a numeric value by using an informat to indicate how the character string should be read. The put function converts numeric values to character values by using a format to indicate how the value should be written. Let's start by looking at the input function. Suppose you have a dataset with a date of joining variable that is defined as character, and you want to be able to do calculations on the date. You can use the input function to do this conversion. The input function has two arguments. The first argument is the source, or the variable that needs to be converted. The second argument is the informat. The informat tells SAS how the data in the input dataset is displayed so it knows how to read it in. Here's some examples of character values, the informat that you could specify to read the value in, and the resulting numeric value. For the width, you must specify a value that accommodates all the characters in the value you want to convert. When the character value includes a decimal point, you do not need to specify a decimal value in the informat to return a numeric value with a decimal point in the same position. If you use a decimal value in your informat when no decimal point is present in the text value, SAS inserts a decimal point at the point specified. In this example, new prices 1 includes a decimal point 2 positions from the right because there was no decimal point in the original value of the price variable. No note, warning, or error message is produced in the log, because this is the intended result of the decimal value in an informat. However, the numeric value in new prices 2 is not an accurate conversion of the price value. Dates can be written as text strings in many different ways. A special informat you can use to read a variety of dates is the NEDTDTE informat. You might be thinking, why not always use it instead of the specific date informats such as date or MMDDYY? One reason is that it does take a bit longer to process the values with the NEDTDTE informat. You also might prefer to use a particular informat to ensure that converted dates all follow a designated layout. But it's good to know you have this option if you are unsure about the format of incoming dates or you're reading a variable that has dates written in various ways. One thing to note when you use this informat: if the date is ambiguous such as May 1st, 2023, which could be interpreted as either May 1st or January 5th. SAS uses the DateStyle system option to determine the order of month, day, and year. The default value for the DateStyle option is locale. So the sequence is based on the locale system option. If locale is set to English, then DateStyle sequence is MDY and 5/1 is read as May 1st. If you need to specify how the date is interpreted, you can set the DateStyle option in an option statement. If DateStyle DMY, 5/1 is read as January 5th. What if you need to change the type of an existing variable? In this example, we have code to change the type of age from character to numeric. However, when the set statement reads the practice.class data, the PDV is established and age is a character variable. The assignment statement cannot change the character variable, age, to a numeric variable because it's already established. This is similar to how a link statement cannot change the length of a variable after it is set in the PDV. If you want to change age to a numeric variable, there are 3 steps you must follow to change the variable type. First, use the rename equals dataset option in the set statement to rename the input variable you want to change. The rename equal to dataset option follows the dataset name that has the variable you want to rename. You list the current variable name on the left side of the equals sign, and the new variable name on the right. And pay attention to the parentheses. The outer set of parentheses surrounds all dataset options applied to the dataset, and the inner set of parentheses surrounds the variables being renamed. This example code renames the age variable to age_. The variable age_, is added to the PDV as a character variable. Next, in an assignment statement, use the input function with the renamed variable as the source. To the left of the equals sign, use the name of the original variable that you want to be numeric. This adds age to the PDV as a numeric variable. Finally, use a drop statement to eliminate the renamed variable from the output dataset. Now let's do the opposite conversion, numeric to character. The put function can be used to convert a numeric variable to a character variable. The put function has 2 arguments. The first argument is the source, which is the variable that you want to convert from numeric to character. The second argument is the format. The format tells SAS how to display the new character value. Suppose you have a numeric date variable and you want to create a character day variable that has the first 3 letters of the day of the week for the particular date. The put function reads the numeric value in date and converts it to a character value using the format downAIM3. Here's some examples of formats that can be used to convert numeric values to character values. Formats in the put function work like formats that you use to display values. You specify the format, width, and decimal value for how you want the character value to be written. In this example, we'll convert character variables to numeric variables using the input function. And then, we'll convert numeric variables to character variables using the put function. To start with, let's take a look at our input data. I have lab_data open. And I have the variable panel visible on the left side, so that we can see the different variable types. The pyramid with the A means it's an alpha or a character variable. The circle with 1, 2, 3 means it's a numeric variable. So notice that date and fee are both stored as a character value. Dates, of course, we want to make numeric dates. The number of days from January 1st, 1960. And fee should be a numeric value as well. In the fee variable, you'll notice that some observations have a value of n. N means that no fee is paid. So we'll have to do a little work with the date and fee variables to store them properly as numbers. So let's start with this program. I'm reading the laboratory data. And what I'd like to do is create an accumulating variable for total fee, which will be a running total of the fee variable. But remember, right now, fee is a character variable. Let's run that step and see what happens. Just glancing at the output, the results look okay. Let's take a look at the log and see what happened. You'll notice this message. Character values have been converted to numeric values at the places given by, specifically line 72. This is the fee character variable that was found in the code. So SAS attempts to convert the character fee value to a numeric value using an int format. It uses the standard w.numeric int format. So SAS is successful with this automatic conversion when the character value is a legitimate numeric value such as 4. However, SAS is unsuccessful when the value is equal to non-numeric values such as n. When that happens, we see messages in the log. Invalid numeric data, fee equal n. For those instances, a value of n is converted to a missing numeric value. So assuming that n was treated as a missing value for calculating total fee, because we used the sum statement, remember, missing values are ignored. So our accumulating variable is calculated successfully. So we were lucky in this situation. SAS's automatic conversion worked perfectly. Let's go back to the program and add a bit more. Even though we received the correct answer, how could I handle this differently? In other words, could I do an explicit conversion of fee to a numeric value so they don't receive those messages in the log about automatic conversion and invalid values? We can do that with the input function. First thing I'll do is use an if-then expression to handle those values when fee equals n. So, if fee is not equal to n, then I want to create a variable called fee number. That value will be derived using the input function, and I'll read the character variable fee and I'll read the string using the 6.in format. My else condition would basically be anything when fee is equal to n. And in those instances, I want fee number to be equal to 0. Now I'm going to delete the previous sum statement that I had and add a new one that will utilize my new fee number variable. So total fee plus fee number. Now that I'm using the numeric fee number variable in my sum statement, I can go ahead and drop the original character fee variable. Let's see how this looks. I'll highlight this data step and run. Notice in the variables panel, fee number is a numeric variable. The calculations all look correct for our accumulating variable, but let's check the log. Notice there are no messages about automatic conversion or invalid values, even though the results are the same in both examples. In some cases, that can be really important that your log is very clean and does not include messages about automatic conversion or invalid values. So by using the explicit input function, we were able to control the conversion ourselves and eliminate those messages. Let's go back to the program again. Remember the variable date was also character. Let's go ahead and take care of that variable and make it a numeric SAS state. But in this situation, I want my new variable to still be named date. However, recall I can't have both a character input date variable as well as a numeric output date variable. So I'll need to use multiple steps in order to rename the original variable to something else and then create the new variable with the date name. So my first step will be on the set statement. I'll use the rename data set option and rename date as char date. Then in my program, I'll create an assignment statement to generate a new variable named date that will use the input function to read the character date, and the date is in the format mmddyy with the 4-digit year. So the appropriate int format would be mmddyy10. Once I have my new date variable, then I can drop the character date variable. And remember, My new date variable is going to be a numeric SAS date. So I want to be sure to format it so that I can interpret the values. I'll use the date9 format. Once again, let's run the data step. In the results, the date variable looks great. Notice over in the variables panel, I can see that the new date variable is numeric and formatted with the date9 format. So this gives me the best of both worlds. I can see and interpret the dates clearly, but I can also do numeric calculations and sorting. Let's continue manipulating the laboratory data by converting some numeric variables to character variables using the put function. Back in the program, let's move on to the second data step where we're going to use the put function. Before I do anything, let's run this data step and see what we're starting with. You'll notice that we're creating a variable called city_state_zip that is concatenating together the city, just the string MN for Minnesota, and the zip code. The first argument in the catx function, space, indicates that each of those strings will be concatenated together, leading and trailing blanks will be removed, and a single space will be inserted. But recall zip code is a number. Is that going to impact our results? Well, let's see. City_state_zip looks great. The cat functions automatic convert numeric values to character values, and like I said, remove leading and trailing blanks in the converted value. If I look at the log, SAS also does not write a note to the log when values are converted with the cat functions. So those concatenation functions offer some nice flexibility in concatenating both character and numeric values. But let's do something else with that zip code variable. Let's say the last two digits in the zip code represent a certain geographic area. So I'd like to create a new variable called zipCodeLast2, and I'll use the substring function. The first argument is the variable zip code. I'd like to start reading in position 4 and read 2 characters. So how does the substring function deal with numeric input from the zip code variable? I'll run that data step. And notice zipCodeLast2 is missing. And if I look at the log, I see a similar note. Numeric values have been converted to character values. However, we clearly didn't get the result we were looking for. When SAS automatically converts a numeric value to a character value, the best 12 dot format is used and the resulting character value is right-aligned. So the numeric value of 55455 becomes the character value of 7 leading spaces followed by 55455. Clearly the automatic conversion doesn't work in this situation. But that's okay because we can do the conversion explicitly using the put function. So as the first argument to the substring function, I'm going to use the put function to read numeric zip code, and I'll use the Z5 dot format. The Z format will write a number as a character string and insert leading zeros if necessary to fill 5 total positions. So with our first argument in substring, now a character value. Let's rerun the data step. Much better. zipCodeLast2 looks great. When variables in your data are not stored in the proper type for how you want to use them, it can cause a lot of headaches. However, they all can be resolved using put or input. Thanks for watching. I hope you found this video helpful. Don't forget to like and subscribe for more. Until next time, happy learning!